using the magnetometer to determine what is the strength of the magnetic fields at various positions of magnets. So the first thing that you have to understand is this is a magnetometer. Now there is a magnet kept here which is black in color, you can see that, and this red dot indicates the direction of the North Pole. So this is the north direction, and Earth's horizontal magnetic field is going to be exactly aligned along this direction, north to south direction. And then the magnetometer has got two needles, one is this side and the other one is this side, which is perpendicular to the compass needle. Okay. Now the way to set up a magnetometer first is make sure that the 0, 0 line, you can see that the 0 is here, 1 0 is here, another 0 is here. The 0, 0 line is aligned along the arms of the magnetometer. So you can see the scale here. The scale is basically the arm of the magnetometer, okay, arms of the magnetometer. So 0, 0 line has to be aligned along the arms of the magnetometer, and then what you have to do is you have to rotate and make sure that this center of the magnetic needle is also bisecting the arm. Okay, that is very important. You cannot keep the magnetometer shifted like this to one end so that the center is completely offset. So the center has to be center, and the arms of the magnetometer, which is in this direction, they should be exactly along the arms of the magnetometer. Okay. Now what you do is you rotate the entire system as a whole through slightly till the compass needle reads 0, 0. So compass needle reads 0, 0. Now when you do this, you have set it for the adjustment. If you have set it for 0, 0 alignment along the arm, disturb the system. So then the magnetometer is ready for use. Okay. So when this happens, what is effectively happening is your Earth's horizontal magnetic field, which is in this direction, and we will be keeping two magnets along the arms in this direction. So the magnetic field of the magnets, which will be in this direction, will be exactly perpendicular to the Earth's horizontal magnetic field. Okay. So when I keep the magnets there, this compass needle will lie along the resultant of these two magnetic fields, which are perpendicular to each other, Earth's horizontal magnetic field as well as the magnetic field of the magnets. It will be perpendicular to each other, and the compass needle will be lying along the resultant of these two magnetic fields. So just to demonstrate that, I will bring in the magnets, two magnets. So if you notice here, there is a dot here on the magnet. This dot indicates the North Pole, and so you can see that both the magnets have the North Poles. Okay, dots you can see on the other side. So the way you have to keep the magnet on the arm is, if the North Pole of one magnet is pointing in this direction, the South Pole of the other magnet should point in this direction. So you can see that the North and South are connected like this. So this is the way you have to keep the magnets. Okay. So now what you do is you keep these magnets at equal distance from the center of the compass needle. So that is, this distance from here to here should be same as the distance from here to here. Okay. Now what I am showing you is a very exaggerated picture because I cannot show you the complete scale, and you will see that in this particular case the deflection is almost rotating the magnetic needle to lie along the magnetic direction, magnet itself. So if I move this magnet backward, it will go out of the field of view. You will see that the compass needle will deflect lesser and lesser, and you can see the deflections. Okay. I don't know whether you are able to see the needle exactly. So right now the needle is pointing in this direction. Okay. So the reading is roughly about 45 degrees here, this side, and about 50 degrees this side. So two things you have to be careful about. One is the center and the magnets. I'm bringing the magnet again close to each other so that you will be able to see it. The center and the magnets are all lying in the same line. That's the first thing. Second thing you have to notice is that the distance from here to here is exactly same as the distance from here to here. Okay, these two things you have to be careful about. And the third thing which you have to do is the distance of the magnet should be adjusted such that the deflection is between 30 and 60 degrees. Okay, so for example, if I move it backward, you will see that the deflection is now come to roughly about 40 here and 40 here. So theta 1 is 40 degrees, theta 2 is 40 degrees. So in your tabular column, what you have to do is, I'll show you the tabular column also. It's a very lengthy tabular column which combines both the things. So if you notice, the first column is here. First column is basically showing you distance of the magnets. So distance of the magnet is basically from the center, how much is the distance to this point. Okay? This is only for a reference work. So this distance is what you are going to write it here as distance to the distance of the magnets. Okay? Now I showed you when the magnets are kept like this. Notice what I'm just tilting it sideways so that you can see it more clearly. Suppose I'm tilting it sideways, you'll see that this side is north and this side is south. So the magnetic field is actually from north to south in this direction. Okay? And the Earth's horizontal magnet is perpendicular to this, and the magnet compass needle is lying along the resultant of these two. Now you notice this is theta 1, this is theta 2. So you note down what is the value of theta 1 and theta 2. Now what you do is, without altering the distance, you reverse the direction of the magnetic field. How do you reverse the direction of the magnetic field? You just turn them around. Okay? When you turn them around, you notice that the north pole has become here and south pole is here. So the magnetic field direction has been reversed. Okay? So once it has come into rest, you note down theta 3 and theta 4. Now what you do is, at the same distance, you interchange the two magnets. Once you interchange the magnets, you take theta 5, theta 6, then you again reverse the magnet, then you will get theta 7, theta 8. Okay? So if you look at the tabular column, at one distance, you write down here what is the distance. You have noted down theta 1, theta 2, theta 3, theta 4, theta 5, theta 6, theta 7 and theta 8. And I told you how to take the readings. And once you've taken all these readings, you find out what is the mean theta. So that mean theta value is known to you. And once you know what is the mean theta, you can calculate the value of tan theta. And once you know tan theta, you can calculate the value of the magnetic field strength when the magnets are kept at this distance, at the center. Okay? That magnetic field strength is going to be called as B, that is equal to BH tan theta. Okay? Is this part clear to you? So at this particular distance of the magnet, what we have done is we have estimated what is the strength of the magnetic field at this point, which is given by this B is equal to BH tan theta. Okay? So this completes the first part of the experiment. So what you have to do is, at few distances, maybe 3 or 4 distances, you measure what is the strength of the magnetic fields and tabulate them. Only condition being the deflection should be lying between 30 and 60 degrees, not as high as what I am showing it here. Okay? Absolutely clear. I hope all of you have understood this part of the experiment. Now what you have to do is, without disturbing the system in any way, you're going to just lift up the compass box, and at the same place you're going to keep a CRT. So the CRT is here. I don't know whether you can see it. I'll just take the camera out and then show it to you, the CRT. So you can see the I'll just you can see the CRT here, and CRT has got a tube. This is a tube which you are going to consider, and high voltage is going to be applied at the back, which is going to be connected to the instrument related to that. So that part we'll show it to you now. Let me pause the video here.